Today, I would like to present the instrumentation system for the measurement of weight from 0 to 5 kg. For the project background, on the research, there is a lot of recent and advanced technology that already been commercialized in the market nowadays. For example, the company from the China that produces smart measuring scale that connect by using Bluetooth sensor and Wi-Fi. This product also has a great accuracy weight measurement and has many other functionalities such as calculating BMI, fat and the blood pressure. For this instrument system project, the objectives are to design and develop an instrument system for the measurement weight from 0 to 5 kg. Then we need to calibrate the proposed instrument system and investigate the accuracy of the system. Next, we move the instrument system design. The instrument design we start with the mechanical design, which is content of overall system description. Next is physical design of the enclosure, which is the product or the component that we are used for making this instrumentation system. And then lastly, we do an engineering drawing to get an accurate dimension of the product. Next, we move to the electrical design. For electrical design, we start with the sensor section. The sensor section that we are using is the load cell. The 5 kg of the load cell. There be as a transducer with a length of 80 mm width and height 12.7 mm. Then for the signal conditioning system modeling and the design, in this condition, the gain we are decided is 200 in order to prevent the OPM from missing the saturation because the output will be remain the same no matter how much weight is on the load cell. The signal condition of this modeling we are considered two voltage follower, two inverting amplifier, and a differential amplifier. Then we do a schematic diagram. Number 4, we draw the circuit diagram. And lastly, we decide the component. We decide uh, the component that we are used for this system. And we move to the how the system works. System work start with the input of the coding program in the Arduino, as you can see in this image. In the Arduino, the program will declare some important variables such as sensitivity, verbal offset, and enabling serial monitoring. And to process the analog value, the program will need to take sum of 90% of the 16-volt band and 10% of the average. And the system proceeds to calculate the burden from the calibration equation and save it inside the correct variable. Then we print out or we display the program output, the analog value. Then finally wait to the serial monitor with a delay of 1000 milliseconds for readability. And this is an example of the output display that we get from the system.
Okay, Assalamualaikum warahmatullahi wabarakatuh, and a very good day. Today I would like to demonstrate the functionality of the instrument system. First thing we need to do is to create a program coding for the instrument system. We put integer val equal to 0, float offset equal to 36.545, float sensitivity equal to 31.382, and we float prefix and the curve weight. And then for this program coding, we print out the analog value and the weight. After we finish create the program coding, we will put we will upload the program coding into the Arduino using Arduino Uno. By following this schematic circuit diagram, we start to connect the electronic component, which is the Arduino with the capacitor and the OPM 741. After finish connecting all the wire, then we also need to connect the load cell with the Arduino and the capacitor. Finally, we put the load, which is 10 gram of water on the load cell, and then we display the output.